Okay, so remainder theorem. There's my drawing pen. Okay, so actually the remainder theorem is like very similar to your factor theorem, right? So for example, if you have your polynomial and you divide by x minus a, for example, x minus 2, then the remainder will be equal to P2. Okay, so this would actually give you the remainder. So you don't actually need to do the division. Okay, like down in the example here, you don't have to divide that to find the remainder because I don't want the quotient. Okay, so the other case is if you have a polynomial and you divide by ax minus b, for example, 2x minus 3, then the remainder is p b on a. So that would be 3 on 2. And that would give you the remainder there. Okay, so it's just a modification of this rule here. If you forget how to do this, just let that equal 0. And then 2x equals 3, x equals 3 on 2. So that will give you the number you need to put into your equation, okay, to get the remainder. So I'll do the first example, then you can do a couple down here. Hopefully you haven't done it yet, but I don't know what you're up to in the morning, so let's just clear that. So if you're dividing by x minus 5, in this case, the a value in your formula, remember your formula is x minus a, so then a must be 5. Okay, so this is the number you need to put into the polynomial to get the remainder. So your remainder is going to be P5, and then you put 5 into your dividend there. So 5 squared plus 3 times 5 minus 2, okay? So this would give you 25 plus 3 5s are 15. You can copy this onto your sheet if you have it, or copy in your notebook. Minus 2, so what's that? 25, 35, 40, minus 2, 38. Okay, so this would be your remainder if you're dividing x minus 5 into x squared plus 3x minus 2. So we can try that actually. So just to waste a bit of time. So let's do x minus 5 into x squared plus 3x minus 2. So x squared, you'll get x squared times minus 5, minus 5x. 3 minus negative 5 will be 8x. Bring down your minus 2. This is going to have to be 8, yeah? 8 times x, 8x. 8 times minus 5, minus 5, 8, minus 40. And then we subtract them. Minus 2 plus 40 is 38. That's your remainder. So in a test, if I say, give me the remainder, and I don't want the quotient at all, you don't have to divide it. So just do your remainder theorem, okay, which is these two here. So if I just want the remainder, use those. It will save you some time. Because the division, you may end up making a mistake anyway and get the wrong answer. So I think you're more likely to get it correct if you do it this way here. And on some tests, if we have a test, I don't know when that's going to be, but I may ask you to use the remainder theorem. So you'll need to do it this way anyway. All right. So are you okay with that? If you want to copy it, I'll leave it there a minute. But on your page, these are your two examples here. Can you do them now? I'm going to give you about what, 10 minutes, 5 or 10 minutes to do them, okay? And then you can tell me what you got for the remainder. So in this case, your a is going to be what? Anyone can tell me? X minus a, so a must be 2 because we have negative. Remember, if this was x plus 2, we'd have to rewrite that as x minus negative 2. So then the a will be negative 2. And we use, okay. So I'll let you work, and then in a few minutes, when you have an answer, you just call out your answer, okay? Okay, get working, and I'll just clean that a bit. And I'll go through it when you tell me the correct answer. Hopefully my answer key is correct. But in question B, you might get a fraction. Okay, when you do question B. I might check with my photo math. I have checked these, I think, but I'll double check. So you work for a while, and when you have a remainder, tell me, and I'll tell you if it's right or wrong.
Teacher,
Yeah?
is A 29?
Yeah, that's right. So I'll let you keep working. So I'll tell you the answer. I want you to try and get the answer correct, okay? So you should get 29, and I just checked that. So you're faster than my photo math. So I'll do the other one, and then all right, okay. Yeah, it's a fraction, the second one. And that one's really ugly because if you divide part B, you're going to end up with fractions everywhere because you got 2 dividing into 3. So it's going to be messy. So I won't divide it. So just do by remainder theorem. Okay, part B, you have an answer?
1/8 is a 1/8.
Could be correct. Yeah, 1 on 8. That's
Okay.
right. That's right, yeah. So just keep doing that till you can get that answer. And if you finish, just wait for a bit and the others can catch up. So if you haven't done it yet, be quick. Okay, so we've got, okay, I'll do the first one because I think, have you finished 29 already? First one? Everyone finished? Got 29? I assume you finished, all right, because I'll move on a bit. So if you haven't finished, you can watch here. So when we're dividing by x minus 2, we think about a formula which is x minus a, which is back here, or x minus a. So in that case, your remainder is going to be equal to P2. Okay, so you're going to get 3 times 2 cubed plus 2 squared plus 2 minus 1. So 2 cubed is 8, 3 8s are 24, plus 4, 2 minus 1 is 1. And 24 plus 4 plus 1 is 29. Okay, pretty easy, isn't it? So that means that x minus 2 is not a factor of this, not a factor, because you had a remainder. So x minus 2, not a factor. Okay, if it's a factor, from the factor theorem, remember this should be 0. You should get no remainder, all right? So in this case, to get 1/8, your p-value, okay, let's just go 2x minus 1 equals 0. So x is 1/2. So that is your a value that you use. So if you forget how to do the formula, just use that little equation and then you'll find the a value. Don't use x, it's a. So now we need to put 1/2 into our dividend here. So 3 times 1/2. I'm going to do this without a calculator. So I think it's a good practice too. So if you haven't done it, if you did it with calculator, just redo it using fractions. So that's a cubed plus 1/2 squared plus 1/2 minus 1. So 1/2 cubed is 1 on 8. So you'll get 3 on 8. Okay. 1/2 squared is 1 on 4. That's 1/2. That's 1. Subtract 1. So what you can do here is when you see all denominators are different, we try to make them the same. So 3 on 8 is good. We can use 8 as our denominator because 4, 2, and 1 divide into 8. So 1 on 4 is the same as 2 on 8, isn't it? As an equivalent fraction. 1 on 2 would be the same as 4 on 8. 4 on 8.5 is the same. And 1 on 1 is the same as 8 on 8. That's negative, subtract. Okay, so now you've got 8, 8, 8, 8. That's your common denominator. 3 plus 2 plus 4 minus 8. If you see any error when I'm writing, say something, because I'll end up, you'll be copying the wrong thing. So 4, 5, 6, 7, 8, 9. Okay, 9 minus 8 on 8, 1 on 8. So in some case, if you don't have a calculator, that's what I recommend to do, okay, that method. Any questions? No problem. Okay, so that's your 2 remainders. Okay, next section is when you get something that's a little bit wordy. Okay, so we've got a polynomial here, a cubic polynomial. You've got one unknown, A. You've got an unknown, and this is what you need to find. You've got one unknown, and you have one piece of information. If you have 2 unknowns, you're going to need 2 bits of information. Otherwise, you won't be able to find your unknowns. Okay, you'll see that on the second one, on your turn. So it says that when the remainder, well, we want to find the remainder when we divide this by x minus 2. It actually gives the remainder, which is 5. So if you look at that form, x minus 2, well, that's in the form x minus a already. So in this case, a is 2. Okay, so when you put 2 into your polynomial, you're going to get 5. So if you put 2 in to here, you'll get 5. You can copy this down if you have your tablet, as I'm doing it. Okay, so this will enable us to find a. So we put 2 into our polynomial. Let me go up my next page, just to keep a track on what I'm doing. All right. Okay, so we've got 2, we put 2 cubed into your polynomial, minus 3 times 2 squared, plus a2, well, I'm going to write 2a, because we normally put the number first, minus 1. So if you substitute 2 into your polynomial, you'll get this remainder 5 there. So the P2, which you would written in here, is not needed anymore. Get rid of it. So now we can find a. So 2 cubed is 8, 2 2s are 4, 4 3s are 12, plus 2a minus 1 equal 5. Can you finish that one for me? What's 2a? So we've got 8 minus 1, or 8 minus 12 actually. So we should move, I'm going to move them all over. So minus 8 plus 12 plus 1 plus 5, correct? So when I moved the numbers across, I just changed all the signs. You could have added them on this side and moved that as well. So 2a is 12 minus 8, which is 4, plus 1 plus 5. That's going to be 10, isn't it? So you're going to get 2a equals 10. So a will be 5, which is what I got on my answer key. So that's good. Okay, I'll leave that there for a little bit for you to copy it. And so you want to have a full, so all these examples, you want to have them all filled up, okay, on your sheet. So I'll leave that there a minute. If you're ready, you can try, I'll leave it there. You can try to the your turn. So if you don't have the file, which is online, so you can go and look online if you want, if you didn't download it yet, because I sent it this morning. So we want to find the remainder when this is divided by, well, we know the remainder actually, yeah, 8. The remainder is 8. And your a value will be -3, because you've got x plus 3. So a will be -3. And your remainder is 8. All right. So you try that one. It's just the same as the one I just showed. Okay. So I'll give you 5 minutes for that. Is anyone still copying this one? No answer? Yes, we have it. Okay. So I'll scroll up so you can fix it up yourself. Okay, so there's 2 here, A and B here. So do A first and then let me know what you get for the answer. So remember for this one, if you're still working, if you're not sure what to do, you need to put in -3. So from the question, P -3 equals 8. Okay, let's just minimize that down. So P -3 equals 8 from the question. Put -3 in. -3 times -3 squared plus 3 times -3 plus 5. And when you calculate that, where's my A gone? Yeah, A's in the front. So then you got 8 on the end here. So simplify each part. So when someone gives me an answer that's correct, I'll do the solution.
Sure, is it 23/9?
No. Oh, 23 on 9. Oh, mine's not simplified, but it's not 23 on 9. I didn't simplify mine. Hold on. But no, can you just double check that?
Is it 23/27?
Hmm?
Is it 23/27?
It's not 23 on 7. No. So let me simplify my fraction because I double checked it, so it should be okay. Oh, hold on, 3. That should be 13, 3. Okay, after I simplify, I get -13 on 9. Anyone get that? -13 on 9. I forgot to simplify my fraction, so I just had to do that. So let's have a look anyway. And then if you're not getting it, we can see what happened. So that doesn't look very good. Okay, so we got -3 cubed, which is -27a. -3 squared is 9. 9 times 3 -27. 3 times -3 -9 plus 5 equals 8. Okay, so these numbers you need to put to the other side. So you're going to have 27 plus 9 minus 5 plus 8, which is on that side already. So -27a on what? 9 minus 5 is 4. So that's 27 plus 4 plus 8. You're going to get 39 here, you see, 39. Is that correct? 39. 8 plus 4, 12. So you got 12 plus 39 here. So you'll come down to here. So -27a is 39. So a will be 39 or -39 on 27. And 3 into 39 is 13. 3 into 27 is 9. That. Did anyone get that? Those who are paying attention. Anyone? Okay, so that's the answer there. It will be on the video anyway. So, but take a look at that. You may have made some error with this part here, with this section here. Okay. Shall we move on? Part B. Okay, is there any more? Oh, that's factor theorem. So if we finish a bit early, I might make up some random question that you can practice. Okay, so in part B, we've got a polynomial. Now you have two unknowns. You see A and B. Here, there's two unknowns in this part. Now, when you have two unknowns, you need two bits of information to find them. Otherwise, it's like if I said x plus y is 10. How can you solve that? We've got one equation, but we have two unknowns. So this has more than one answer, right? So to do these questions with two unknowns, we need two bits of information. So we've got, when you divide by x minus 1, the remainder is 3. So that's telling me now this is x minus a. So a here is 1. So if you put 1 into your equation, you're going to get 3. This will give you equation 1. And the second bit, when it's divided by x plus 2, the remainder is minus 1. So for that one, if you put 2 into your, if you put minus 2 in, remember x minus negative 2. So a here is going to be negative 2. So be careful of that. I nearly made it wrong myself. So p minus 2 is going to be equal to minus 1. So that's how you started. So sometimes the question will involve factors. They'll say this x plus 2 is a factor, okay, which you'll see in the next section. So I want you to make two equations. This will take you a little while to do it if you haven't done it already. So your first equation, P1 is 3. So form an equation using your polynomial here. So let's erase this stuff. So P1 is 3. So put 1 into your polynomial and write equals 3. So 1 cubed plus 2 times 1 squared plus a times 1, which is which is, okay, 1 times a, okay, a plus b, and that will equal 3. This will give you your first equation. So what you need to do here is simplify this. Simplify that first, okay? I'll do it in a minute, but you try yourself first. P minus 2 is minus 1. And then we do exactly the same for that one. So you're going to see this kind of question again for sure, because it's very popular in my materials that I've got. You'll find it in every textbook that does remainder theorem. So put your minus 2 in. So minus 2 cubed plus 2 times minus 2 squared plus minus 2 times a minus 2a. So let's make it minus 2a. If you see an error, say something. So minus 2a and plus b equals minus 1. So this will give you your second equation. So again, go and simplify this down and then tell me what you get here when you fully simplified. You'll get down to another equation. This is equation 1. And do it again. And I'll do it in a minute, but you can see what you get here. And that will be equation 2. And then we need to solve them as simultaneous equations, all right? So I'll give you a few minutes to try that, and I'll be quiet for a bit. So if you're doing this, we've got 1 cubed. I'll do some, you can just check you're working against mine. 1 cubed is 1. 1 squared is 1 times 2 is 2 plus a plus b equals 3. So we still have more to do, don't we? So we've got 2 plus 1 is 3. equals 3. I'll show all the steps. If you bring the 3 over, of course, 3 minus 3 will be 0. So that will cancel. So a plus b equals 0. Right, so that's your first equation. I'll highlight it. Or a equals negative b, for example. Same thing. So for this side, minus 2 cubed is minus 8. Minus 2 squared is 4. 4 2s are 8. Minus 2a plus b equals minus 1. So we still have more to do. Minus 8 plus 8, gone, cancel. Well, that's it. Minus 2a plus b equals minus 1. That's your second equation. It may look a bit different, but it should actually be the same when you rearrange it. So yours may look a bit different, but you can still end up with the same answer. So has anyone finished that one? Can anyone tell me A and B yet?
Is it 1/3? Like B is negative 1/3 and A is 1/3.
Yep, that's right. So you should get, yep, so A is, so did you get A is 1/3? And B is the opposite sign, negative 1/3. Did you get that? Is that Nicole, is it, or Pang? I couldn't tell who it is. Is that correct?
Yeah.
Yeah, these two answers, right. Okay, so if you forgot everything from grade 9, you probably can't find A and B, so we'll do it. So we've got A plus B equals 0, and you've got minus 2A plus B equals minus 1. This is equation 1 and 2. Now, if you see here, you've got B and B the same, which is a good, because when you subtract the equations, the B will disappear. So sometimes it's not that easy, and you have to change them around if you remember back to grade 9, but we're going to see this again anyway. So what I could do then is A minus negative 2A, all right? So that's going to give you 3A, right? B minus B is 0, which is good. 0 minus negative 1 is 0 plus 1. So that will give you 1. So A will be 1/3. Okay, first answer. Not so easy to get by guessing, is it? You've got to work with the equations a bit. So for B, you just choose one equation, and this is obviously the easiest one. I wouldn't bother with equation 2 because it's got other numbers in it. It's a bit messy. So A plus B is 0. A is 1/3. B is something. So if you want B, just move your 1/3 to the other side, right? Like that. B is minus 1/3. So you could go back, you could substitute them back to the equation and check it on a computer graphing program or something, but I probably wouldn't bother. I don't think there's any easy way to check that that's actually correct or not. You could actually put A and B into the equation. What you could do, you could put 1/3 in and minus 1/3. So A is 1/3. B is minus 1/3. You could then divide this into this and check the remainder by division, or you can use the remainder theorem. You could do it, but you would only do that if you ran out of time. Okay. Any problem with that? Is that okay? Now, before factor theorem, here's a question about sets. Right, we need to start sets really soon because we're kind of slow with sets, and we need to finish So if you had a set which is, this is just extra, I'm just filling in a bit of time. Z. Okay, this is your set builder form. Remember set builder form? Some students made error with these kinds of questions. Okay, so we want the values of X that are between 1 and 2. So what are they? That's only 1 and 2, isn't it? Because they're integers. Z is integer, so whole numbers. So that means that X is either 1 or 2, yeah? But that's not your answer, is it? Because the answer you write is this one. This is what you write down, 3x. So if x is 1 and 2, which you get from this part of the question, what is 3x then? So the set A is going to be 3 times 1, because the first value was 1, and then 3 times 2. Okay, so then you're going to get 2 answers, 3 and 6. I'm just telling you that now because I think some students were making errors in this kind of problem, especially here. So you may have another one, set B, X such that X squared 5x is integer as well. In Thai books, they use I. So if you pick up a Thai textbook, they use I for integer. All right. But actually, Z is actually came later. So the Thai book is actually using the old version for integer. So if you do see I, it's not imaginary number, because when I think of I think of imaginary number, not integer. So if you see I in a book, especially in the Thai book, it means integer. Okay. So you'd write, okay, so what would be, so if your first value is 1, so X would be 1 to 5, right? So when you square the number, they have to be between 1 and 5. 1 squared is 1. That's okay. 2 squared is 4. Okay. But when you get to 3, 3 squared is 9. And you're not between 1 and 5. So these numbers no more number can be used. Oh, also you could use, I should do positive integer, because negative integers could give you some answer as well, because -1 squared is 1. So let's stick with positive integer. So then we write down the x squared values. So these are the x value, 1 and 2. So then we'd have 1 squared and 2 squared, which is 4. So 1 and 4 would be the answer there. But I think we'll spend more time on that again later on anyway. It's 11:05. Do you have any more questions? Yes or no? Are you okay with that? Okay, but for sets, yeah, we'll spend a bit more time on that later. Yeah, some notation in Thai textbook is a bit different than in the Western textbook, which when I see that, I'll let you know, because I've got some Thai books as well that I get questions from. So any really hard looking question has probably come from a Thai book somewhere, like an entrance book or something like that. All right, so I think I've talked enough today. Any questions? Are we finished? Yes? Nicole, is that did you become a parasite or what? What is that?
Oh, I'm a potato.
Oh, okay. Looks like a parasite. You have to ask teacher Renee about that one.
Oh my gosh.
I actually want that. I want that. I saw there's some program you can turn yourself into anime, right?
Oh, right.
But I think you have to pay for it, like the good version. So your face will become an animation face. You look the same. You look the same, but you actually look like an animated version of yourself. So, but yeah, I've not seen that before, that one. Okay, shall we finish there? Yes or no? Speak.
Yeah.
Yes.
Yeah, all right. Okay, otherwise I don't know. I'll keep teaching otherwise because we only have a few minutes left. So, all right, I'll talk to you tomorrow and we'll do the factor theorem, all right?